Hi friends, this video covers the introduction of 8086. Let us see, the 8086 is a 16-bit processor. So it contains 16 data lines, generally from D0 to D15. Because of 16 data lines, so the 8086 can take any data from 40H to 4FH. So range is 40H to 4FH. In XR representation, see here every XR number is equivalent to 4 binary bits. So because of 16 data lines, so for example, if all 16 are 16 zeros, so the number is 4 zeros. Assume all 16 bits are 16 ones, then maximum number is 4Fs. So with the help of 16 data lines, 8086 can access data in the range of 40H to 4FH. That's why it is called it as a 16-bit processor because of 16 data lines. Then the 8086 mainly contains two units. One is called it as a bus interfacing unit and other is execution. So these two units are designed for 16-bit only because of 16-bit processor. The bus interfacing unit and execution unit both are designed for 16-bit. The role of bus interfacing unit is every time bus interfacing unit fetching the instructions from external memory or IO device, okay, then decoding it, and later the instructions after fetching and decoding, those instructions will enter into execution unit for execution. The execution unit mainly contains registers, ALU and other arrangements, okay, but both are designed for 16-bit only. Then later the 8086 contains 6-byte instruction queue. Instruction queue. So 8086 can access maximum of 6 instructions, 6 bytes of instructions only, and because it's a queue means it's a FIFO, first in first out. So which instruction will enter into queue first, that instruction will execute first, okay, then later other instruction, like that. The maximum size of instruction queue is 6 bytes. 8086 contains 14 registers of size 16. Total number of registers are 14, but size of each register is 16-bit. So many registers are there, like AX register, BX, CX, DX, and some segment registers like SS, SS, CS, DS, ES, and index registers like SIDA and many other registers. Anyway, in register organization I will explain, but these four are AX, BX, CX, and DX. These four are called as general purpose registers, and some 4 segment registers are available, and pointer and index registers are available, flag register available, okay, stack pointer and base pointer registers are available, like the total of 14 registers, and size of each one is 16-bit. But these 4 registers especially used for either 8-bit operation or 16-bit operation. So if it is AX, X indicates for 16-bit. If you write like this, for example, first register AL, comma AH. So AL is for 8-bit. So name is accumulator lower byte. AH is accumulator higher byte. These two for 8-bit. For example, directly I need to perform 16-bit operation, then we can use AX. So these 4 registers can be used either 8-bit or 16-bit. For 8-bit operation, lower byte and higher bytes are available. For 16-bit operation directly, AX, BX, CX, DX are available. Like that, B also BL, BH, C also CL, CH, DX also DL, DH. Okay, in complete overview of functioning of each register we will discuss separately. So finally we have 14 registers of size 16-bit. Then again 8086 may have clock frequency of 5 megahertz. So the clock frequency of 8086 is 5 megahertz. So what is the meaning of clock frequency? It indicates what is the rate of execution of each instruction. For example, frequency 5 megahertz is time period is 1 by 5 megahertz. So that much time, maybe microseconds of time it will take to execute each instruction. So that gives the speed of the execution. So clock frequency is 5 megahertz. Then other is for performing any operation, the minimum duty cycle here is 33% of duty cycle. Contains other point is it contains 40 pins. So you know already what is duty cycle. Duty cycle means on time plus off time. So the minimum on time should be 33% of total time. That is called as a duty cycle for performing the operation. Okay, then it contains 40 pins. Okay. So actually in those 40 pins, some are multiplexed pins and some are normal pins. Let us see what is multiplexed means. So instead of taking only for one function of that pin, so we are using the same pin for multiple functions. Maybe some are address lines, some are data lines, like that. Some pins are multiplexed pins. So how many are present means generally 8086 contains 16 multiplexed address and data pins. Directly 16 address lines and 16 data lines are not available. They are multiplexed means combination. So 16 address lines are present along with 16 data lines. Here AD0 to AD16. So here A0 to A16 are address lines. Similarly D0 to D16 are data lines. So to know they are not directly address and data. They are multiplexed. So we should separate for our operation. So if you go for any operation, so first we should separate address and data lines into pure address lines and pure data lines with the help of external latches and ALE signal. But because of multiplexed facility, so number of pins are reduced. Otherwise what happens, we are taking 16 address lines, for that we need 16 pins, and 16 data lines we need another 16 pins. Total 32 pins are required. In order to avoid that, so here only 16 pins are present. So 16 contains address and data combining it. That's why it is called as a multiplexed. And 4 more address lines are multiplexed with status lines. So 4 address lines are multiplexed with status lines. But A16/S32, A19/S6. So where A indicates address and S indicates status. So A16 to A19 means total 4 address lines. They are multiplexed with 4 status lines. So the status lines may have separate functioning. Okay, we'll discuss what is the functioning of each status later. Finally, total 16 multiplexed address and data lines are present, and 4 address and status lines are present. So total 20 multiplexed lines are present. So in order to separate these multiplexed lines into pure address lines, we use latches. But generally each latch can separate only 8 lines into pure address lines. But here total 20 address lines are present. So we need 3 latches. Okay. So because of 20 address lines, the 8086 can access 1 megabyte of memory. So why 1 megabyte means it's a 2 power 20 address lines. 2 power 20. So 2 power 20 is 1 megabyte. So because of 20 address lines, we have 1 megabyte of memory it can access. So 20 means A0 to A90. So the range of memory accessing address range is 50H to 5FH. So for example, if you consider A0 to A19, all are zeros, 20 zeros. So equivalent XI is 50H. This is the starting address accessing limit. And similarly, assume 20 address lines are all ones, then ending address is 5F. So the 8086 can access a maximum of 1 megabyte of memory, that is because of 20 address lines, and because of 20 address lines the address range is 50H to 5FH. Then again 8086 can access 2 power 16 IO devices. So 8086 can access or can communicate it to 2 power 16 IO device. 2 power 16 means 65,536. 2 power 16 means 65,536 IO devices it can communicate. So it can access to 65,536 IO devices. It can communicate. One processor can communicate it to this many IO devices. What is IO means? Input device, output device, like that. Maybe 8255, maybe 8257, like that. Some other ICs. So those ICs also communicated to processor. Maximum 65,536 IO devices can communicate it to one processor. Then again 8086 operate in 2 modes. One is called it as minimum mode. Another is maximum mode. So 8086 operates in 2 modes, minimum mode and maximum mode. In minimum mode, all control signals are generated by processor only. Means for suppose I need pure address lines and pure data lines. So for that I need some control signals. So if it is in minimum mode, all those signals are generated by processor. Whereas in maximum mode, all control signals are generated by external bus controller. So there is a one separate IC. With the help of that IC, 8086 may generate separate address and data lines. Simply in maximum mode, 8086 simply gives command to external bus controller, and external bus controller will activate other trans receivers and latches. Accordingly, it will separate multiplex address and data lines into pure address lines. So whereas in minimum mode, the entire work is taken care by processor only. Whereas in maximum mode, the activation, everything will be controlled by external bus controller, but command is given by processor. Okay, so here the 8086 requires 5 volts power supply. It requires 5 volts power supply. Okay, and the 808, one important function of 8086 is so it supports pipelining mechanism. Pipelining mechanism. So let us see what is pipelining mechanism. So in old versions of in older versions of microprocessor like 8085. So in that also we have two units, like already I mentioned, DIU and EU. So in those previous versions of microprocessors, if one unit is fetching the instructions, other unit is ideal. So for example, if you take bus interfacing unit, so it will fetching the instruction, whereas execution unit, it will execute. But whereas in previous versions, whenever a bus interfacing unit is fetching, execution unit is ideal, it won't execute. Similarly, whenever execution unit is executing, bus interfacing unit won't fetch. So only one operation is taking place at a time in older versions. But because of pipelining mechanism, so in 8086, fetching and execution both are done simultaneously. Means the bus interfacing unit will fetch the instructions. Similarly, during this time, execution unit will execute the previously fetched instructions. For example, one instruction is already fetched. That instruction will be entered into execution unit, and it will execute. So during this time, bus interfacing unit will fetch next instruction. So because of that, it will take less time to execute all the instructions. That's the advantage of pipelining mechanism. Okay, so this is about some of the important points of 8086. Thank you.